Welcome to the Executive Protection and Secure Transportation Podcast, brought to you by the International Security Driver Association. The ISDA is a valuable resource for all practitioners working in the protection profession. We offer benchmark educational, networking, and marketing programs. Hello, and welcome to episode 165 of the Executive Protection and Secure Transportation Podcast. I'm your host, Larry Snow. The topic for this week's episode is safety, security, and the science of G's. Ensuring the passenger's safety and security requires the driver to have the knowledge, skill, and experience to control the vehicle when confronted with an emergency. The emergency does not necessarily need to be a security scenario. It can often be an accident-producing situation. As we have mentioned many times in the past, research and science define driving skill as the driver's ability to use the vehicle's capability. Former Vehicle Dynamics Institute or Scotti School students know that we were and are anal about training our students to maximize the vehicle's capability. The more the vehicle's capability the security driver can use, the higher the probability that the driver will avoid an accident or other life-threatening scenario. To pass the Vehicle Dynamics Institute course or be certified as an ISDA Security Driver, a driver must demonstrate that they can use a minimum of 80% of the vehicle's capability. The simple scientific fact is that every 0.1% that the Vehicle Dynamics Institute can train the driver's ability to use the vehicle's capability is a life-saving skill. But it is hard to conceptualize how a 1% increase in a driver ability increases the principal and passenger safety and security, hence an explanation is in order. Safety, security, and the concept of G's. We need to explain the G-forces effect on the driver principal vehicle safety and security. The best way to understand a specific vehicle's safety dynamics is by understanding how G-forces affect the driver vehicle's capability to stay in control. Anytime the steering wheel is moved while the car is in motion, a lateral or sideways force is created. This force is pushing in the opposite direction the car is turning. The term G's is a measurement of the force acting on the car. It is this force that determines if the driver can stay in control of their vehicle. 1/10 of a G can make the difference between avoiding a potential accident or vehicle attack scenario or not. Let's put this into working exercises. In the first scenario, at a given speed, if the path of a 4,000-pound or 1,814-kilogram car is altered in a way that produces 1 G, that 1 G of force is equivalent to 4,000 pounds or 1,814 kilograms of force pushing on the vehicle's center of gravity, or in shortened form, CG, pushing the vehicle away from its desired path. There's a simple equation that is used to determine the amount of force pushing on the vehicle, and that is the amount of force pushing on the car is equal to the G's multiplied by the vehicle's weight. So let's take another scenario, we'll call it B. At the same given speed in the previous scenario mentioned, or we'll call it A, if we turned the steering wheel of our 4,000-pound, 1,814-kilogram car in such a way that 0.7 G was created, then we would have created 2,800 pounds or 1,270 kilograms of force. We came to those numbers by multiplying the vehicle weight times 0.7 Gs. If the car weighed 3,000 pounds or 1,361 kilograms and the steering wheel was turned the same number of degrees at the same speed and the vehicle took the same path, the equation would read 3,000 pounds or 1,361 kilograms times 0.7 Gs or 2,100 pounds or 953 kilograms of force, and so on. Understand the lateral g-forces created in a turn are based upon both the vehicle's speed, weight, and how much the steering wheel is moved, or the degree or sharpness of the turn. The purpose of using G's as a measuring tool. G's are used as a measurement of driving skills and method of testing vehicle capability. The purpose of using G's instead of weight for a measuring tool is because saying that there are 2,800 pounds or 1,270 kilograms of force being exerted on the car does not tell us very much. The 2,800 pounds or 1,270 kilograms of force number is meaningless unless the weight of the car is also known. For instance, if 3,000 pounds or 1,361 kilograms of force is exerted on a 5,000 pound, 2,268 kilogram car, then that's no big problem. However, if you take a corner in such a way that 3,000 pounds or 1,361 kilograms is being exerted on a 2,000 pound or 907 kilogram car, you're in big trouble. It's far easier to say this vehicle is designed to absorb 0.7 Gs. If we use a 5,000 pound, 2,268 kilogram car for this example, then 0.7 Gs means that the vehicle can absorb 3,500 pounds or 1,588 kilogram of force before becoming unstable. If we use a lightweight 2,000 pound or 907 kilogram car, then that 0.7 Gs is the equivalent of 1,400 pounds or 635 kilograms of force. So Gs multiplied by the weight of the car equals how much weight or force is pushing on the car. Now, to the original question, why for decades have we been adamant about ensuring students reach 80% or more of the vehicle's capability, and while conducting training, the instructors will spend an inordinate amount of time ensuring you can use every tenth of a G the vehicle offers? The answer: a tenth of a G could mean the difference between surviving or not surviving. Here's an example. Using the science of driving and applying metrics and equations that are familiar and often used in accident reconstruction technology, we can conceptualize the value of adding 0.1 G to the driver's skill level. If the vehicle is traveling at 40 miles per hour or 64.4 kilometers per hour in a vehicle-driver combination that can handle at 0.85 Gs, and there was an object or barrier that measures 10 feet or 3.1 meters wide in front of the driver, they would need approximately 49 feet or 15 meters of distance to clear the barrier. With all the parameters the same as we just mentioned, such as the vehicle position and speed, the 40 miles per hour, the 64.4 kilometers per hour, with a vehicle driver combination that handled at 0.7 Gs, rather than the 0.85 Gs, the driver would need approximately 55 feet or 17 meters of distance to clear a barrier that is the 10 feet or 3.1 meters. If traveling 40 miles per hour or 64.4 kilometers per hour, again, with the same vehicle driver combination that handled at 0.6 Gs, the driver would need approximately 59 feet or 18 meters distance to clear that barrier of 10 feet or 3.1 meters. Same scenario, traveling at 40 miles per hour, 64.4 kilometers per hour, but now with a vehicle driver combination that handles at 0.5 Gs, the driver would need approximately 65 feet or 19.8 meters distance to clear a 10 feet or 3.1 meter barrier. With all the parameters the same, such as vehicle position and speed, which is the 40 miles per hour, 64.4 kilometers per hour, but now with the driver-vehicle combination that can handle at only 0.4 Gs, they would need approximately 72 feet or 22 meters of distance to clear that same barrier. So as you can see, every tenth of a G that you can use gives you more time and distance to drive out of the problem. This is why computers are needed to measure the driver's ability to use the vehicle's capability. These measurements can be computed using a radar gun and accurately measuring the vehicle's path through individual exercises. understanding the concept of lateral acceleration as a must for a security driver. That will bring us to the end of another episode of the Executive Protection and Secure Transportation Podcast. I hope you'll join us next week for another episode. Show notes for this episode are available at the securitydriver.com website. While you're there on the website, be sure to sign up for the Executive Protection and Secure Transportation magazine. It is one of the oldest protective service publications in the profession. The magazine was first published in the mid-1980s. At that time, it was a quarterly newsletter read by the protective service community. The magazine covers all facets of the protective services profession, and many of the articles are authored by the ISDA members with an average of 18 years of experience. The Executive Protection and Secure Transportation magazine is of value to all practitioners working or entering the protection profession, and it's free. The magazine is read by practitioners managing executive protection and secure transportation from over 300 Fortune companies, security personnel for high net worth families, private security companies, and various military government agencies. So make sure to sign up for that. Also, if you haven't done so already, make sure to subscribe to the podcast in your favorite podcast app, whatever you're listening to right now. Please subscribe. And if you've been listening for a while, let us know what you think by leaving us a review. We'd really appreciate that. It helps us get some acknowledgement from the community, and it helps us get recognized by those nasty algorithms. And we'd really appreciate it. And if you enjoyed this week's podcast episode, we invite you to check out the International Security Driver Association, get access to the Encyclopedia of Executive Protection and Secure Transportation, the ISDA Knowledge Center. The knowledge shared encompasses a wide range of executive protection and secure transportation-focused topics with resources, information, and metrics. For more information on all the member benefits, head on over to isdacenter.org.